Welcome to EDU World Space.
So in this question, we are given the state of the stress acting at a point on a wrench in the figure, and we are required to determine the smallest yield stress for steel, right? For steel that might be selected for the part, and it should be based on the maximum distortion energy theory, right? So let's start with the solution. Now the solution is very simple. um we are given by the figure of the problem that we have sigma sub x that is equal to 300 megapascals, and sigma sub y that is equal to 0 megapascals, right? And we have sub xy that is equal to 150 megapascals, right? Now we are required to solve the smallest yield stress, right? So to use for that, we are going to use equation 10.30, and this equation, it describes the maximum distortion theory, and for this we are required to find the principal stress, right? So we are required to find out the principal stresses, so that would describe the maximum distortion theory. Now for these maximum sorry for these principal stresses, we are required to use the equation 9.5, right? So let's use it. Now sigma sub 1 would be equal to sigma sub x sigma sub y divided by 2 positive under root sigma sub x negative sigma sub y divided by 2. This under root is, sorry, this parenthesis encloses this whole fraction, right? Whole square plus sub xy square, right? So just plug in the values and we'll get that sigma sub 1 is equal to 362.1320. That is approximately equal to 362.13 megapascals, right? And similarly, you will find sigma sub 2. So its equation is sigma sub s sigma sub y divided by 2 negative, excuse me, let me write it neatly. So under root parenthesis sigma sub x sigma sub y parenthesis close divided by 2 positive sub xy square, right? Again, just plug in the values and we get that sigma sub 2 is equal to negative 62.1320. That is approximately equal to 62.13 megapascals, right? So now that we have the principal stresses, right? Now these principal stresses are just, let me just write them once again in a combined form, right? So sigma sub 1 is equal to 362.13 megapascals, right? And sigma sub 2 is equal to negative 62.13 megapascals, right? So as you can see that they are opposite in sign. This one is positive and this one is negative. So it means that uh, for the maximum distortion theory, right, we just need the principal stresses, and as they're negative and they're different, they're opposite in signs, right? So the correct form of the equation 10.30, it would be sigma sub y is equal to sigma sub 1 square sigma sub 1 times sigma sub 2 plus the square of sigma sub 2, right? As you can see, we have a positive sign over here, so it means that we need to take the under root of this equation, and that would be sigma sub y under root sigma sub 1 square negative sigma sub 1 sigma sub 2 plus sigma sub 2 whole square, right? So just plug in the values and we'll get that sigma sub y is equal to 396.8627. That is approximately equal to 396.86 megapascals. Now, as you can see that at this value, right? At this value, the value of yield stress, um, the material just fails, right? The material just fails. Therefore, this is the smallest value, right? This is the smallest value we can take for the yield stress for this material, right? So this concludes our answer, because at this value the material, it just fails. So it means that this is the smallest value for the material, and this concludes our answer.